Hi, welcome to Bubble Shot approach. This is the simplest shorting algorithm when comparing with other shorting approaches, which is traversing the elements from first index to last index in given array. In each iteration, the current element is compared to next element in the given array. When we comparing the current element with the next element, if the current element is greater than the next element, then we will apply the swapping process. For example, here the given array is having 5 elements: 11, 3, 6, 15 and 14. In the iteration number 1, we are comparing 11 with next element 3. So here the 11 is greater than the next element 3. So we have to swap this both. So 3 is coming into the first position and 11 is going to the next position. Then again we are comparing the current element 11 with the next element 6. So here also the 11 is greater than the 6. So here we are applying the swapping process. So when we are swapping, 6 will come into the second position and 11 will come into the third position. So 11 is here now. So current element is 11. Again the current element 11 is comparing with 15. So 11 is here less than 15. So no need of swap. No need of swap. Then here the current element is 15. Thus 15 is compared with the 4. So now 15 is greater than the 4, so we have to apply the swapping process. So after swapping, 15 is uh, available in the last position. This is the current element now. So now the array is over. Then we have stopped this iteration number 1. So at the end of the iteration, the largest element is placing its right position. You look at that, after the 15 there is no element, so 15 is the largest element in the given array, which is placed in the right position. So that is the thing. So when we are comparing the elements for each iteration, at the end of the each iteration, the largest element is placed in its proper place. That means, what is the meaning in the bubble sort here? The largest element is bubbled up at each iteration. The largest element is bubbled up. So here the largest element is here in the given array 15. So it is bubbled up and placed in the right position, proper position in the given array. So that's why it is called bubble chart. Then next iteration, here we can traverse from the first index to the last index minus 1. So it is already sorted. It is already sorted. So we can traverse until the position 3. So n minus 2, n minus 2. Okay, so this is because we are starting from 0th index. So this is n minus 1, 4 is the n minus 1. Then now we can traverse until 3, so n minus 2. So now the first element is again compared with the second element 6. So 3 is less than the 6, no need of swapping. Then current element now I is in the j is second loops, j is incremented 1. So now the 6 is the current element compared with next element 11, which is again less than the 11. Then we need not to apply the swapping. Then now the current element is 11. So 11 is compared with the next element 4. Here 11 is greater than the 4, apply the swapping. So after swapping, 11 is placed in this position. So now the current element is 11. Again 11 is so we have stopped here. We have stopped here because we are moving until n minus 2. So now 11 is placed in its right position, placed in its right position. So the element 11 is bubbled up and placed in the right position. So for each time, for each iteration, the largest element will be bubbled up and placed in its right position. So in Java, we can apply this. First, we have to take the length of the array. So length of the array is here 5. The first iteration is, we are starting iteration number 0. We are starting with, so here the length is 5. So 5 minus 1, 4. So here I less than 4. The condition is true. Then in the 0th iteration, we are going for loop. In the for loop, here j equal to 0. Then j less than, length is here 5. So 5 minus I value here 0, here 1. Okay, so this means it will be 4. It will be 4. The condition is true now. So 0 less than 4. 0 is now, j is 0. 0 less than 4. Condition is true. So here what we are doing, we are checking. First we are checking a of j greater than a of j plus 1. So here a of j here 11. A of 0 greater than a of 1. That means current element is greater than the next element. So now we are checking based upon this condition, 11 greater than 3. Yes, it is true. When it is true, what we have to do, we have to apply the swapping. So after swapping, this 11 will come into the next position, 3 will come into the 0th position. So now in the iteration number 0 for the jth loop. Again, j is incremented by 1. So now j equal to 1. J equal to 1. So now we are having 11 is the current element. So this is the 1. This is the 1. So under j equal to 1, so 1 less than, now length minus I. Length minus I here, again 5 minus 0. So 5 minus 0 minus 1. So it is 4. So again the condition is meeting out 1 less than 4. So now again we are checking here the first element with the next element. That means a of j with a of j plus 1. That means a of j is 1 greater than a of j plus 1 is 2. So now as per this, here a of 1 is 11 greater than a of 2 is 6. So now this is also true. If it is true, we have to swap it out. So after swapping, our array will be looking like this. So our array will be 3, and now 11 is swapped with the 6. So 6 will come here, 11 will go here, then 15, and last element is 14. So this is the index 0, 1, 2, 3, 4. So now again j is, after swapping, j is incremented by 1. So j equal to 2. So now we are checking 2 less than 4, right? So 5 minus 0, right? Length 5 minus 0 minus 1. So 2 less than 4. Yes, it is true. So when it is true, so now we are checking a of j. A of j is now 2. A of j 2 greater than a of j plus 1 is 3. So a plus 1 is 3. So now the value of a of 2 is 11. So 11 is here 11 greater than 15. J plus 1 is 3. So this one. So we are checking the current element with next element 15. So now this is false. So once it is false, then this if loop will not execute. It will go back again. J is incremented by 1. So j equal to 3 now. So now 3 less than 4. Less than 4. Length minus I. Length minus I. 5 minus, this 4 came from length is 5 minus I value is here still 0, then minus 1. So that is the 4, right? So now this is true. When it is true, then we will check the if condition. In the if condition, a of j is here 3, a of 3 greater than a of j plus 1, 3 plus 1, 4. So now based upon this condition, now we are getting what is the a of 3? A of 3 is 15. So 15 greater than a of 4. So a of 4 is here 4. So this 15 greater than 4 is true. So when it is true, we have to apply the swapping process. When it is true, we have to apply the swapping process. So once it is swapped, our array will look like 3, 6, 11. Now 15 and 4 are swapping. So here 4 will come into the 15 place, 15 come into the 4 place. So now you look at that, the uh, value 15 is swapped, then j equal to 4. J is incrementing now again. So when j is incrementing by 1, so now 4 less than 4, this 5 minus 0 minus 1, so this is false. Once it is false, the iteration for the j is over, coming out from the jth loop. Once it is coming out from the jth loop, then I is incremented by 1. When I is incremented by 1, we are getting the I is 2. So now the j loop is over. So jth loop is this one, right? Jth loop is this one. So now we are going back to the ith loop. So I is now incremented by 1. So 1. So then again we are coming back to the j. So here again j equal to 0, right? So then we are checking j is 0 now, 0 less than length minus I minus 1. So length is here 5 minus I value is 1 minus 1. Why we are taking this I value in the sense? Because you look at that in the previous iteration, in the iteration number 0, the 15 is bubbled up and placed in the right position. So now we need not to check the 15 once again. So we have to traverse from 0 to index number 3. So we are getting 5 minus 1 which becomes 3. So 0 less than 3. So in the jth loop, we have to iterate or traverse from the 0th index to only the until third index, because 15 is already placed in the proper place. So like that again you have to traverse here. So the next is if a of j greater than a of j plus 1. So here a of j is a of 0 is 3, a of j plus 1, that is 1. So 3 greater than 6, so this is false. So likewise you have to keep on again iterate one by one. So at the end you will get the array will be sorted out. So here based upon this you look at that jth loop is running for n times. Jth loop is running for n times, right? So I is also running for n times. So n into n, right? So the time complexity is big O of n square. Best case is there is swapping will not be applied. Okay, best case is if array is already sorted out, then no need to no need. So if already sorted array is available in the sorting manner, 3, then 4, then 6, 11, 15. If it is the input array, then here just we will apply the ith for loop. So now we will traverse from first index to last index. But here you look at that whenever we are checking a of j greater than a of j plus 1, so always it will be false. So no need of comparisons. So at that time best case will be order of n. But average case, suppose um, half of the array is sorted out, and half of the array is not sorted out. Okay, at this condition, so here this half of array is not sorted. So at this time again we have to traverse here swapping to be applied for half of the elements. So again that will be coming for like n by n minus n by 2. So n into n minus n by 2, it will come like this. So we have to take again order of n square. So this is the time complexity for bubble sort. Thanks for watching.